Good morning everyone, welcome back on our YouTube channel Physics Made Easy Kota. In this lecture we are going to study about the chapter current electricity. Electrons can also drift and that velocity is known as a drift velocity of electrons. Actually this is the average velocity because electrons are free to move, so we can calculate the average of the velocity with which these free electrons in any conductor get drifted whenever there is an application of the electric field, and these electrons always get drifted in the direction opposite to the direction of the applied electric field. We know that in a metal conductor there are an extremely large number of free electrons, and these free electrons move randomly with a thermal speed at a room temperature. The electrons move freely in the conductor, so we can take any portion of the conductor as these electrons move freely, so their average thermal velocity can be taken out as a zero, as their total result becomes zero. Whenever an electric field is applied across the conductor, then these free electrons get a particular direction in which they start accelerated, and they accelerated in the direction opposite to the direction of the applied electric field. When the electrons get accelerated, they gain some extra velocity, but this velocity is just for the short time, because when electrons accelerate they start colliding with the ions in the conductor, and during this collision that extra velocity gained by the electrons get destroyed in this process. Then again the electrons again get accelerated, again the collisions occur, and again it come to the rest. Therefore we can conclude that the motion of electrons in a conductor under the influence of the electric field is like a go and stop motion. As a result, the electron acquire a small average velocity which we call as a drift velocity, in which the electrons get drifted from one portion to the another, but always in the direction opposite to that of the applied electric field. Flow of electrons with drift velocity from one end to the another end of the conductor makes an electric current in a conductor. Suppose we are increasing the temperature of any conductor, and with the increase in the temperature the electrons move faster as they are more freely to move inside the conductor, but with this collisions also increases, and due to the collisions they collide with the atoms or the ions of the conductor and come to rest faster. The drift velocity of electrons decreases with increase in temperature of the conductor. When electrons get drifted from one end to the another end of the conductor, then there is the production or the rise of the electric current. Whenever we talk about the electric current, there always a resistance. Resistance in actual is the opposition to the electric current. Whenever we applied the electric field, then if we increase the potential, then the current in the conductor also increases. So we know that V directly proportional to I. After solving the constant, that is by solving the directly proportional sign, we get the constant capital R, and V is equal to IR. Cross multiply the terms, we have R is equal to V upon I. Here R and I always varies inversely to each other, and the SI unit of resistance is ohm. Resistance depend upon the few things of the conductor, like it depend upon the length of the conductor, it also depend upon the area of cross section of the conductor, and it also deal with the nature or the material of the conductor, that is called as a rho, resistivity of the material. We all aware about the electric current, but there are the various types of the electric current. Like the first one is a steady direct current. Steady means that does not change with time. That is that type of the current which is direct, and its magnitude and the direction does not change with change of the time. But there is another type of the current that is a different form of the direct current which get to vary with the time, and its magnitude change with the time, but its polarity remains same. That is, there is no fluctuations in this direct varying current, and the current which deals with the fluctuations, that is its polarity get changed, is the alternating current. Now here is the time for a little assignment, some subjective questions. Name the current carriers in the solid conductors, liquid and gases. Write a relation between the coulomb and an ampere. What do you mean by the varying current? The SI unit of the current density. And the last one is a numerical. Thank you for watching. Take care. Keep watching our